Okay, so the next thing that you should have seen in the reading was stuff about electric force and magnetic force. Now, these are related to each other because they both have a positive and a negative charge, so they work together, basically. And when we get into electricity, you'll understand more, obviously, about these two forces, but you have to understand that they do belong in the force family because it is a push and pull relationship. Okay, I want you to think about magnets. When you put, Jacob, two positives together, what happens? Yep. They push apart. When you put a positive and a negative together, what happens, Justin? They connect or they pull together. So it's a push-pull relationship. Okay, so you have when charges from one piece of matter interact with another piece of matter, they produce an electric and a magnetic force. This fan is driving me crazy. Okay, so what you need to know about magnetic force is that it decreases with distance. The farther apart the magnet is from something metal, then it will not be as magnetic as if they were really close together. Okay. So after magnetic force, we have centripetal force. And we talked about centripetal force a little bit on Friday with the Angry Birds. Now, first of all, centripetal force is a force that causes something to move in a circular path. So if you're on a roller coaster and you go up the hill and down the hill and then around the loop, centripetal force will keep you in the loop. So why, if the centripetal force will keep you in the loop, why do you need to wear the shoulder harnesses if it's going to just keep you there? Jacob. Well, centripetal force keeps you from falling and dying. As long as you're moving forward. What happens if you get stuck upside down on a roller coaster, which has happened to me before? It's not fun. Hanging there for a little bit. What happens? Brendan, you fall out, which is why, thank goodness, we had the harnesses, because otherwise we'd be falling right out and then they'd have a lawsuit on their hands. Okay, now we talked about gravity and centripetal force with the Angry Birds space on Friday, and the difference in size between the large planet and the little planet, and how the little planet has less gravitational force than the big planet. So when we shoot the bird into this force field, this gravitational force is greater, so it's going to pull that bird out and then swing it around the planet a couple times before it hits the angry piggies, right? Okay, so the weaker gravitational force because it has a smaller mass, and this has more gravitational force because it has a larger mass. And I know you guys don't have this in your notes because I drew this on my own, and we know that the textbook does not have Angry Bird references in it. So you're probably going to want to draw these because don't be surprised if they don't end up on your constructed response, okay, for your test on Wednesday. Questions about Angry Birds, yay. Okay, the next thing that we're going to talk about, first I want to remind you, don't forget to study the Angry Birds stuff that we've covered because that's going to be your constructed response for your test. And you might want to check out the YouTube video from Friday because I posted that onto the YouTube site. So make sure that you check back with that also. So let's talk about friction because friction is always something that you guys have a difficulty understanding. Because usually when we use the word increase, you think it means to go faster. But when we talk about friction, it's actually the opposite. So think of friction as opposite in general, because when you have friction between two objects in motion, it's opposing motion, okay? Opposite direction. Show me friction with your hands. I know you guys all can. All right, good. Okay, you're moving in opposite directions. What happens when you go real fast? It gets hot. Okay, remember that because I'm going to refer back to that. Okay, show me how you can increase friction. How can you increase your friction? Oh, it's good to see that not all of you are going faster. Okay, increasing the friction. What do you need to do with your elbows to increase the friction? Push harder. Okay, if you're rubbing your hands together and you push harder, are you able to move your hands as quickly? No, because you've increased the friction. In order to increase friction, it makes it harder for the objects to slide past each other. For example, if we increase the friction, we can add sandpaper. Like sandpaper on sandpaper, very difficult to move back and forth. You could make it stickier. What could you add to your hands to increase the friction? Glue. Perfect. Okay, now this is my picture. This is like the last time, one of the last things that happened to me before I decided I was moving to Las Vegas, when my car was filled like 6 feet with snow, like up to the side, and I had to dig it out. It took me like 8 hours to dig it out. It was ridiculous. Okay, so I don't even know why I dug it out, because like, where am I going to go anywhere in my Mustang convertible in 8 feet of snow? Okay, so let's pretend that this doesn't look like grass. It started out as snow, and then I got lazy over here, so it kind of looks like grass, but it's supposed to be snow and ice. And if you talk to anybody who's really from the Midwest, in those places where you get a lot of snow, just about every person I know or knew would always either have a bag of salt or a bag of sand in their trunk, because number one, it weights down the back of your car and prevents it from sliding all around. And number two, when you get stuck, it's great to have that in your trunk, because then you can use it to your advantage. Now, what's happening here? What's happening here? I'm trying to add friction, because if this is snow and ice, and that's my arrow, it's not really a good one. What's happening to the wheel, though? It's spinning. And if you spin on snow, it creates friction, which creates what? Heat. And if you add heat to snow, what happens to it? It melts. And then when it's like 30 below outside and the snow melts, what instantly happens? It freezes and turns to ice. So if you have your sand in your trunk and you pour the sand underneath here, it creates friction, allowing you to move forward. Does that make sense? Instead of spinning out. Okay. So we've increased the friction here, allowing us to move forward. Okay. To decrease friction, to make it easier for objects to slide past each other. So if you're rubbing your hands together, you can add less pressure. What else could you put on your hands? Soap. Some of you could learn that probably. So soap on your hands, that's a good thing. Hand sanitizer, very slippery. Okay. Lotion is usually the first thing that people think of. And then I want you to think of a water slide. How many of you have been on a water slide before? Okay. Imagine going down a water slide that doesn't have water running on it. Not boring. You have a bathing suit on. Okay? Not boring. Owie, right? You're going down the water slide without that extra slipperiness, okay? You're not going to go very far. And if you do, you're probably going to cause a lot of friction between your tuchus and the slide, okay? Tuchus is one of our favorite words at our house. And so it's just nicer than saying butt. Okay, so if you go down the water slide, you're like, wee! If there's water. If there's not water, you're like, ow! Okay, all the way down the slide. You've decreased the friction by taking the water, or by adding the water. Does that make sense? How many of you have ever slid down a slide at the park in July with shorts on? How many of you have experienced that friction? That is not fun, okay? Now, on your study guide, I would like you to make sure that you add, I forgot to add it, that air resistance is a form of friction. So somewhere on there you need to understand that air resistance is friction. Why is it friction, though? Why is a parachuter friction? Or a parachute friction? Brendan. You're causing friction in the air. But remember the definition of friction? Opposing motion. Opposite motion. So when you have the parachute is going in what direction? Down. And the air is going up, causing it to inflate and prevent you from dying. Okay? So when you go, if you jump out of an airplane without a parachute, you're going to be like, ah! And then if I was jumping out of an airplane with a parachute, I'd probably be going, ah! Because it's still scary. Okay, so air resistance, frictional force that air exerts on a moving object and acts opposite in direction to an object's motion. So there will be questions about air resistance actually being friction. So make sure you get that.